Hello again, and welcome back to Operations Management. In this session, we'll be talking about statistical process control, one of the 7 tools of quality. Statistical process control, also known as SPC, is a way that we can monitor a process. We have particular standards in place, and then as the process is running, we're going to take measurements, compare them against those standards, and if necessary, we'll make corrective action. And all this is happening while the product or service is being produced. This is part of what's known as the feedback control principle. We have a process, we evaluate the performance, collect information, and then make a decision as to whether we need to change the process. So it's a feedback loop. We know that inside the process there's going to be variation. It could either be normal variation or abnormal variation. And what we need to do is figure out the differences between the two. Natural or normal variation is to be expected. Every time a process is happening and every time we produce a product, there's going to be some slight difference between one product and the next product. If you think about when you sign your name, every time you sign your name, your signature looks a little bit different, and that's to be expected. That is natural variation. What isn't to be expected is what's known as assignable variation. Let's say you're signing your name and somebody bangs your elbow, and suddenly your signature looks a little bit different, or in some cases, significantly different. This is a variation that can be traced to a particular cause. That's why it's called assignable. We can assign a cause to it. In statistical process control, what we're trying to do is determine whether the variation is natural or due to some sort of cause that we then have to go and correct. We use control charts, which are a graphical presentation of data over time. We have predetermined control limits, so if a variation exceeds that control limit, there's a problem. If a variation goes below a lower level limit, there's a problem. But it's very easy to see on a graph. This is all based off the central limit theorem. If you recall from your days in statistics, you realize that when you have a population and we take samples from that population and we take the means of those samples, that tends towards a sampling distribution of the mean, which is looking somewhat like a normal distribution. And so we use that when we set up our control limits. Here we have the normal distribution. It's a nice bell curve. And if we're trying to capture as much of the natural variation as possible, in most cases we define those control limits to be 3 standard deviations above the mean and 3 standard deviations below the mean. That means that we're capturing 99.74% of all that natural variation that goes on in a process. So if something falls outside of those limits, we're pretty sure that it's due to an assignable cause. So let's take a look at a control chart. Here we've captured means of samples over time, and there's a lot of variation there. But right now we can't tell whether that variation is natural or whether that variation is due to particular causes. So now once we've added the normal distribution there, we can see where that normal distribution spreads, and if we take 3 standard deviations above and below the mean, we now have upper and lower control limits. And we can see that most of that variation actually falls inside those control limits, so that would be natural variation. But we also have 3 points that fall outside of these control limits. This is what we would look for in terms of assignable variation, because it is now beyond 3 standard deviations away from the mean. It is most likely due to an external cause. So that's generally what we do with control charts. In the next session, we're going to talk a little bit about inspection and how we actually develop those control charts. I'll see you then.